Yeah, hi everyone, Mr. Marco here again. Today I'm going to go through a couple more examples, or 4 examples exactly, referring to solving linear equations. These ones are a little bit more difficult than what I've looked at in my previous video. In this video, I've got four equations that either have brackets or variables on both sides of the equal sign. And by the time we get down to example 11D, you can actually see there's brackets and a variable on both sides. We'll work our way towards that, but in the meantime we'll start just with example 11A and we'll walk through that process together. Now, previous video I've shown you how to expand brackets using the distributive law, and that's what we're going to do here with question A, or example A, is to remove those brackets first by expanding using the distributive law. The distributive law tells us that we multiply the term in front of the bracket by each term inside the bracket. So let's start with 2 times by 3x, which is 6x. And then we do 2 times by negative 4, which is negative 8. Okay, I haven't changed anything on the left-hand side apart from expanding those brackets. So I haven't changed the weighting, so it's still equal to 11. Okay, and now I can go ahead and solve for x. Now again, in a previous video I've gone through solving some simple linear equations. The process I use is to keep the equation balanced and try and isolate x. Okay, so I've needed to get rid of that 6, which is in front of x, and that minus 8, which is a separate term from the variable term. So I'm going to remove that minus 8 first. And I'm using the inverse operation, which means the opposite operation. To do that, the opposite of subtract is to add. So to get rid of the minus 8, I add 8. And if I do that on the left-hand side of the equation, that's what I'm talking about, keeping the equation balanced. I need to do the same on the right-hand side. Now, I've actually cancelled out the 8 from the left-hand side of the equation, and I'm just left with 6x over there. On the right-hand side, however, I've got now 11 plus 8, which is equal to 19, and that equation is still balanced. Now I can go ahead and remove that 6. Now remember, the operation happening between 6 and x is multiplication, so it's 6 times by x, and the inverse of multiply, the opposite of multiply, is to divide. So we're going to divide by 6. If I do that there on the left-hand side, I also need to divide by 6 on the right-hand side of the equation. Now times by 6, divide by 6 cancels it out. I'm left with, on the left-hand side, x equals 19 divided by 6, which doesn't go nicely. So we're just going to leave that as an improper fraction of 19 over 6, or you can write it as a mixed number, 3 and 1 over 6. Okay, let's move on to example 11b. Again, I've got some brackets, so the first step is to expand those brackets using the distributive law. Okay, I'll keep talking about that and I'll keep walking through the process every time I do it. But remember, it's the term in front of the bracket by each term inside. So let's start with 2 times x, which is 2x. And then we move to 2 times positive 3, which is plus 6. Okay. On the left-hand side, I've still got this other term here, which is minus 4x. That stays there for the time being, and that's all equal to 8. Okay, now, again, in a previous video, we've spoken about like terms and how we can collect like terms. You can see that on the left-hand side of the equation, I've got 1, 2, 3 terms, and of those 3 terms, 2 of them are what we call like terms, because they have the same variable. So 2x and minus 4x are like terms. So I can collect them, I can add them together. But in fact, I'm not going to add them because this is a minus 4x, so I'm going to do 2x take 4x, which is actually minus 2x. Okay? Keep the 6 there as the constant term, and again, that's still equal to 8. I haven't done anything in terms of changing the weighting, I've just expanded the brackets here, and I've collected like terms here. Okay, next step now is to solve for x, and we're going to start by, getting rid of that 6 because it's furthest removed from the x at this stage, so take 6. If I do that over there, that's right, I need to do it on the right hand side too. Plus 6 minus 6, they've cancelled each other out. I'm left with minus 2x is equal to 8 take away 6, which is 2. And then I need to remove the coefficient of x, which is minus 2. Now remember, what's happening here between the minus 2 and the x is multiplication. So the opposite of multiplication, or the inverse operation, is to divide by minus 2. I don't add 2 here. Okay, that's a very common mistake. If I divide by negative 2 on the left hand side, I need to divide by negative 2 on the right hand side. Okay, I'm just going to move this down a little bit so we've got a little bit more room. There we go. So I'm now left with, on the left hand side, x, and that's equal to 2 divided by negative 2, which is minus 1. 2 divided by 2 is 1. A positive divided by a negative is a negative. Okay, so in that case, x is equal to minus 1. Alright, let's move on to example C. No, that's example D. Let's look at example C over here. Now, in this example, I don't have any brackets, but I do have a variable on both sides of the equal sign. So at this point, I need to remove x from one side. The way I do it, and there's more than one way to do it, is I target any negative values of x. Neither of those are negative. They're both, that's a positive 5 and that's a positive 3x. In that case, I target the smaller value. So I'm going to get rid of the 3x. Because it's a positive 3x, I'm going to take 3x. And if I take 3x from the right-hand side, I actually need to take 3x from the left-hand side too. So what I've done there is essentially I've cancelled 3x, all that variable, altogether from the right-hand side. 3x take 3x is 0x. There's no point in writing that. Left with now on the on the left-hand side, 5x take 3x, which is 2x. Constant term of minus 2 stays there, and that's equal to, this is a minus 4 on the right-hand side. Okay? Now I can go ahead and solve for x again. I'm going to start by removing the constant term of negative 2. Opposite of minus 2 is to add 2. If I do that on the left-hand side, I need to do it on the right-hand side. And I'm left with 2x equals minus 4 plus 2, which is minus 2. Okay, now again the operation happening here on the left-hand side between the 2 and the x is multiply. Opposite of multiply is to divide. I need to divide by 2 on both sides to remove the 2 from the left-hand side, that is. I'm left with x equals minus 2 divided by 2. Again, that's minus 1. Okay, now looking at example D, we've got a bit of a mix of both of those problems. We have brackets on both sides, and we've got a variable on both sides. First thing I'm going to do is expand. Let's expand the brackets first. So, distributive law, the term in front, multiply by each term inside. Let's start with 3 times by 2x, which is 6x. I'm going to do 3 times by 4, which is positive, so positive 12, and equals 8 times by x, which is 8x, and then 8 times by 1, which is 8. Okay, at this point, I've got x on both sides of the equal sign. Just like in example C, I'm going to remove x from one side. Which one do you think I'll remove? Will I remove the 6x or the 8x? So I'm going to get rid of the 6x. I'm going to take 6x from the left-hand side, and I'm going to take 6x from the right-hand side. 6x take 6x is 0x. I'm left with 12 on the left-hand side. And 8x take 6x is, let's try that again, is 2x. The 8 stays there. Okay, the next step, solve for x. This time, the x is on the right-hand side for the first time, I think, out of these 4 examples at least anyway, but still the same process. We're going to remove the 8 first. Opposite of add 8 is to take 8. And if I do that on the right-hand side, I get to keep the equation balanced by doing the same on the left-hand side. So I'm left with 12 take 8, which is 4. And that's equal to just 2x. Okay, again, on the right-hand side, 2x means 2 times x. The opposite of times by is to divide. If I divide by 2 on the right-hand side, I divide by 2 on the left-hand side. I'm left with 4 divided by 2, which is 2. And those 2 times by 2, divide by 2, cancel each other out. I'm left with 2 equals x. And if I wanted to flip that around, I can do that too. X equals 2. So there you have it, guys. 4 examples. They're a little bit more in depth or a bit more complicated than what we've previously been looking at. With today's examples, each one of these will refer to a specific question from the textbook if you're in my class. And again, those questions are up on Dame Up. I'll show you quickly what I mean. This is example, let's go here, 11A, 11B, 11C, 11D. And each one of those examples refers to your question from your textbook. So for example here, 11A, 11B, 11C, and 11D. Okay, guys, like I said, have a go. If you're not sure, please send me a DayMap message, and I'll endeavour to get back to you and help you as soon as I can. Thank you.